students, welcome back as we continue this earth-shattering topic. Ladies and gentlemen, yesterday we began talking about plate tectonics, and we talked about the processes really involved in the movement of these plates around the world according to the theory of continental drift. We talked about the various forms of evidence used to support this theory. Well, today we are going to be picking up where we left off in our notes in order to discuss more specifically the boundaries that exist between the plates, otherwise known as plate boundaries. And as we're discussing this, notice this first little animation, and you will see how the theory of continental drift suggests that the continents themselves are moving around from one location to another. And here's a starting point, and notice the location of fossils. And as the continents split apart, or move or drift around the globe, you can see how what once in the past was closer together drifts to the present location much further apart. So this is a pretty good animation depicting or showing how the initial formation of fossils, certain fossils, took place when the continents were together. We'll talk more about that today, and to their present location. But let's continue with the different kinds of plate boundaries. More specifically, plate boundaries are the places around the world, the places where plate edges meet on Earth's surface. And remember, we are talking about just the surface of the Earth. This doesn't extend all the way to the core, to be sure. But the plate boundaries are those places where the plate edges, and we mentioned those various plates yesterday, where they meet on the Earth's surface. And the reason we're going to be taking some time today to discuss these plate boundaries is because they're not all the same. In fact, we're going to be talking about essentially three major differences between these plate boundaries. And these differences account for various types of geological formations and the various types of activities associated with them. Right now in the news, you may have heard about earthquakes and volcanoes around our planet. Many of these earthquakes and volcanoes are a direct result of the plate boundaries that exist around the world. So this is a pretty relevant topic for today. So let's jump right into it with our first plate boundary called divergent plate boundaries. And you'll notice all these hyperlinks in the video, in the presentation here. I do encourage you, when you check your notes for a homework, be sure to click on all of these hyperlinks and check out the little clips and the animations that exist for each one. So let's begin with divergent boundaries. Notice the arrows here in this illustration. We'll see how the arrows are moving away from one another. That is key in divergent, because this is what is happening, for instance, in the mid-ocean ridge that we mentioned yesterday. Imagine this is the Atlantic Ocean, the middle of the Atlantic Ocean, known as the mid-ocean ridge. This is what is actually happening. There is molten rock material bubbling up in the middle of the ocean. There are lots of volcanoes and hydrothermal vents at the bottom of the Atlantic Ocean. And as new material is built up, notice the conveyor belt-like movement away from this divergent boundary. In fact, this is something that we're going to discuss here. Divergent boundaries describe the areas where plates are moving apart from one another. Now, this isn't the greatest picture, but it's a picture of one of my nieces who is visiting Iceland. And on the island nation of Iceland, it is on a divergent boundary. It's right along the mid ocean ridge of the Atlantic Ocean. And this is a picture here, believe it or not, where we can see the North American plate and the Eurasian plate actually spreading apart from one another. And here she is on a bridge. I don't know which side she's actually on, whether this is looking north or looking south. But this is a plate boundary, the divergent plate in the mid ocean ridge. So divergent boundaries are typically found along mid ocean ridges, like the one in the Atlantic Ocean, which extends really from the North Pole all the way down to Antarctica. The entire Atlantic Ocean has a mid ocean ridge submerged beneath it, which has this continuous conveyor belt like motion in opposite directions. Now, divergent boundaries are also known as something. They're also called constructive boundaries. Constructive boundaries. Now, look at the word that I underlined. Underline it in your notes too. That word constructive probably looks and sounds like construction. And there's good reason for that. It's because it is. Constructive boundaries are those boundaries where new land is forming, or more generally speaking, new plates are forming. It might or might not be above the surface of the ocean, but there is new plate material being constructed. So as a divergent boundary is moving apart from one another, new material is being formed. Key part. In fact, circle the word divergent, circle the word constructive in your notes, and draw a line between the two of them so that when you're studying your notes, you make that connection between divergent moving away and the formation of new material. All right, that brings us to the second plate boundary called convergent boundaries. And as you might imagine, convergent boundaries are essentially the exact opposite of a divergent boundary. Divergent boundaries, you've got material coming up and moving away. Well, check out the arrows in this diagram. With a convergent plate boundary, we've got plates moving together. And funky things can happen with convergent plate boundaries. But again, when things converge together, it means they're coming together. So convergent boundaries are those locations around the world where plates are coming together. They go together like ding-a-ding-a-ding. All right, so convergent boundaries, the plates are moving or coming together. Now, most convergent boundaries around the world are found near trenches, ocean trenches, or mountain ranges. In fact, the deepest place on planet Earth, the lowest elevation on planet Earth, is a place called Marianas Trench. It's about 39,000 feet below sea level. It's 10,000 feet lower than Mount Everest is high. So it's pretty deep. It's very deep. It's off the coast of the off Filipina Islands in the South Pacific Ocean. But this trench is near a convergent boundary. Other convergent boundaries also include places where mountains form, like the Himalayan mountains. The tallest mountains on planet Earth are near a convergent boundary, where the plates are coming together. Now, as plates come together, whether they are causing the plates to move up or causing the plates to move down, in either case, when plates are coming together, these boundaries are also known as destructive boundaries. Just like divergent boundaries that move apart from one another are called constructive because new plate material is being formed, convergent plate boundaries are called destructive because plate material is being, well, destroyed. There's less of it. As you move plates closer and closer together and they merge together, they converge, they're destroying one another. Whether they destroy one another in the formation of mountains or they destroy one another in the formation of trenches, there's just less plate material. So that's the second type of plate boundary, convergent. In your notes, I'd encourage you to do something. Circle the word convergent, circle the word destructive. Put a line between those words so that when you are studying your notes, you remember that convergent boundaries are destructive boundaries. Okay, that brings us to the third. These are called strike slip boundaries, also known as transform boundaries. We're going to call them strike slip boundaries. And notice the arrows here. Notice the arrows are going in opposite directions, but they are next to one another, moving in opposite directions. Strike slip boundaries. There's one famous example of a strike slip boundary in the world, and it's right here in the United States, and it's near Los Angeles. It's the San Andreas Fault. The San Andreas Fault is right along a strike slip boundary. And you can get a lot of buildup of forces moving in opposite directions until you have a major earthquake. Well, strike slip boundaries are those that grind horizontally. They grind horizontally, horizontally next to one another. And these are those that form what are called lateral faults or cracks in the ground. The San Andreas Fault can be seen from an airplane above. It is a gigantic crack in the ground. You can see how the course of streams or rivers has changed, how fence rows or forests have shifted in their location. Mountains have shifted because of these lateral faults or these cracks in rocks. Now, one more point about strike slip boundaries is that they are also called conservative boundaries. Now, don't confuse this with politics. This is not conservative as opposed to liberal. It's not that kind of terminology here, but rather a conservative plate boundary is one in which there is no construction and there is no destruction of plate material. In other words, it's kind of status quo. The plates just remain intact, more or less. So there's no destruction, no construction, but both plate materials are conserved, meaning not destroyed or built up. So in your notes, circle strike slip, circle conservative, and draw a line between the two. Okay? When you study your notes, know that a strike slip boundary is the same as a conservative boundary. Now, I want to show you videos of these different types of boundaries during our class period. So I am going to end our plate boundary video for now, as I say, bye bye.